This presentation is about plans to use digital sensors to reduce the risk of surface water flooding across West Yorkshire and further afield, where flooding is devastating for both residents and businesses. We will be covering 1. Why surface water flooding is a huge concern in the region. 2. How is LoRaWAN technology being used by other local authorities and why it shows promise as a solution. 3. What have we done so far to explore using this smart technology? And 4, finally, what do we plan to do next? So what's the issue? Surface water flooding is a growing problem across West Yorkshire, disrupting residents and businesses and causing substantial damage to properties and infrastructure. Currently, 325,000 properties in the UK are at risk from surface water flooding. These properties have a 60% chance of flooding in the next 30 years, and this figure will increase with urbanisation and climate change. The winter storms of 2015 to 16 cost the UK around £1.6 billion in damage. Both regionally and nationally, surface water flooding is poorly understood. There is no comprehensive record of surface water flooding incidents across England, nor any comprehensive assessment of the underlying causes. Risks are localised, modelling is weak, and therefore the specific location, extent and magnitude of flooding is challenging to predict. Local investigations are inconsistent in quality and not centrally collected. This reduces our opportunities to learn from them. As we have no systems in place to give us early warnings of this type of flooding, our response is reactive rather than proactive. This is an inefficient use of resources and doesn't enable organisations to work together to tackle the problem. There is no comprehensive real-time monitoring system or data collection and analysis outside of local authority incident reports. This means there are fewer opportunities to identify the level of risk to specific areas and properties. These are essential for decision-making and securing long-term investment in strategic flood risk management. In comparison, flooding of watercourses, such as rivers and culverts, are well monitored with established rainfall and river warnings and alerts, whereas surface water is difficult to predict. To come up with a solution to this problem, the leaders of the West Yorkshire Flood Innovation Programme, known as the West Yorkshire FLIP, successfully bid for £97,000 from the discovery phase of round 6 of the government's local digital fund, to explore whether using smart technologies could help. West Yorkshire FLIP is an innovative programme launched by the 5 lead local flood authorities to make the region more resilient to flooding and climate change. The Environment Agency, Yorkshire Water and West Yorkshire Combined Authority are also partners, and they have support from academics, community-based groups and third sector organisations. The Yorkshire Integrated Catchment Solutions Programme, known as ICASP, based at the University of Leeds, provides an evaluation framework and scientific lead, ensuring the latest research is embedded into the programme. A project team led by Wakefield Council, working with Leeds and Kirklees local authorities, the Environment Agency and ICASP, has been investigating using LoRaWAN, a long-range, wide-area network, as a viable flood warning system. LoRaWAN uses a network of digital sensors to transmit real-time surface water levels to a central hub and create an early warning system of potential flooding. Operational flood risk managers within highways, emergency planning and digital programme teams in local authorities and the Environment Agency can have accurate information quickly to gain real-time knowledge of where surface water flooding is likely to happen. This allows them to take preventative action sooner, such as activating flood defences, road closures and doing maintenance work, including clearing drains. Flood teams can direct resources where needed and communicate with communities at risk, giving them more time to prepare and put plans in place to reduce any impact. If successful, the plan is to roll the digital sensors out across the region to improve its resilience to flooding, and then to introduce them further afield.
So what has happened so far during the discovery phase of our 12-week scoping exercise? Our project team has held discussions with many different types of organisations involved in managing flood response in Leeds, Kirklees and Wakefield about the key challenges they face relating to surface water flood mitigation and what opportunities LoRaWAN could bring. We have held workshops with flood wardens and community groups, council digital leads, flood managers within the Environment Agency and representatives from West Yorkshire Fire and Rescue Service, Yorkshire Water and West Yorkshire Resilience Forum to find out more about their practical experiences of dealing with flooding and their technical expertise. Together, we have examined flooding issues, hotspots, the pros and cons of digital sensor systems, how information and data is currently collected, platforms and technology which may be used, and what investment is needed. We have also had some useful discussions with Norfolk County Council, where LoRaWAN is already widely used and has proved to be successful. During this scoping phase, we have carried out a review of current incident data and produced hotspot maps to show key areas to target for surface water flooding. We also produced a business case for alpha stage funding to move on to the next stage, which is to develop a pilot scheme to test LoRaWAN's ability to improve surface water monitoring, infrastructure maintenance, and our response to flooding. During our discovery phase, LoRaWAN technology has emerged as a promising solution to the issue of surface water flooding. So let me tell you a bit about how it works. LoRaWAN is a low-energy, wide-area network which enables long-range communication using radio frequencies via the AM network. It allows data to be transferred from remote, battery-powered sensors to user-friendly dashboards. Data is collected on a regular basis from digital sensors and sent encrypted to a gateway. The gateway receives the information and securely transmits it to the organisation's dashboard to be processed and displayed. The dashboards can be customised to show the data in graphs, maps or tabular forms and send alerts to the response teams if needed. Sensors are available for many different applications, including using new bollard sensors for surface water, live data from locally placed rain gauges, soil moisture and gullies. This information can be used to make decisions about maintaining flood infrastructure, flood mitigation or responding to flood incidents. All organisations involved in managing flood risk can access the data in real time via a shared platform. Historical data is available to help analyse what happened during the incidents and detect long-term trends, which can then be shared with partners across boundaries. This could be via an app, a website or using software such as Resilience Direct. So here is a summary of some of the key benefits of LoRaWAN. It is recognised internationally as being a reliable system for sensor data collection. Once the gateway and dashboard have been established, it can easily be scaled up and has multiple users. So other services may use the network for things like monitoring air quality, footfall, temperature and humidity. LoRaWAN is a cost-effective system to introduce compared to traditional monitoring solutions. A network of data collection points can be built quickly, given the existing network of gateways we already have in the region. Its technology allows long-range communication between sensors and gateways, enabling large areas to be monitored for surface water flooding. Its sensors can provide highly accurate data on water levels, enabling early detection of potential flooding. This enables a targeted, proactive approach to help flood managers maintain infrastructure, provide a better response to floods, and carry out analysis of incidents. Data can be available in real time to help flood managers make better decisions. It can show the extent of surface water flooding and timing of incidents at specific locations. This can be used to create an early flood warning system to target hotspots. Service providers, members of the public, flood wardens and community flood action groups can have access to the data. LoRaWAN sensors consume little power, which means that they can operate for prolonged periods of time on a single battery charge.
So let's now examine 3 case studies to show how LoRaWAN is being used. The Wetherby case study. Teams from Leeds City Council are working along with Andel, an environmental technical solutions company, on a project in Wetherby near the River Wharfe. 2 LoRaWAN water level sensing bollards are to be placed near the car park in Wetherby, which is known to flood. You may have seen in the local news images of cars immersed in water right up to their roofline. One bollard will be placed in the river to show the height of the river as it rises and falls naturally. The other sensor will be placed on the bank to show the water level if the water rises above the bank and breaches it. In the event of flooding, the first sensor will show increasing water level and alert that there may be a breach of the bank. The second sensor will allow the flood level in relation to the car park to be monitored. The bollard alerts will be connected to social media, so members of the public will receive advance warning of flooding and enable them to move their cars to a safer location. Both bollards will be connected to the nearest LoRaWAN gateway. The air quality study. An air quality network is in the process of being created in Leeds, in collaboration between Leeds City Council and Leeds University with Dr. Jim McQuaid at the university. Once sensors have been configured, they will continually connect and transmit data between the sensor, the gateway and the cloud, and the resultant data will be presented and logged on an environmental dashboard. At the University of Leeds, the sensors were placed alongside purple air sensors to baseline and check they were operating correctly and also compare outputs. Then the sensors were installed in an air quality observation box outside the Corn Exchange in Leeds, again comparing the outputs to other air quality sensors. There is now a growing network in Leeds of air quality sensors which will send data to the nearest gateway and are then visualised on an environmental dashboard. COVID footfall mapping. During the COVID pandemic, sensors were placed on lampposts to count footfall across Leeds. This was linked to a publicly available online map so users could see how busy a shopping area was. The data was shown in a very simple manner using a traffic light colour system which highlights how busy shopping areas were and then indicates this information on an online map. The website was created through a third party called Parallax. A traffic light system on a simple map could work for many similar use cases, especially in a public-facing capacity. These are some of the many ways in which LoRaWAN is being used already by local authorities. There are 110 gateways across Norfolk and well over 50 gateways in West Yorkshire, which are openly accessible and free for public use. Some of the use cases are as follows. Adult social care, which is used to monitor and manage well-being. Digital telemetry to monitor temperature, humidity and the direction of sails on windmills. The dashboard even draws in local weather forecasts. Monitoring traffic hotspots with heat maps. For example, at Gresson Hall, a large workhouse museum and traditional working farm. Temperature and humidity can be measured in public buildings, for example, libraries and community hubs. Alerts can show when traffic lights and street lamps have malfunctioned. And also measuring noise pollution and air quality, which was done to show the impact of electric vehicles on the road network. Monitoring water and river levels by placing depth sensors under bridges. A few examples are the Vauxhall Bridge in Great Yarmouth and the River Wharfe near Wetherby. This data then goes back to the authorities to alert when the water is high and provide appropriate warnings to the members of the public. And finally, monitoring and controlling street lighting infrastructure and also monitoring night flights at local airports.
So what's next? A pilot is necessary to see if a realistic and credible digital sensor system can be created, managed and maintained. we will need to test the viability of the system and requirements for the organisations involved. To systematically build a resilient digital system, a step-by-step approach is needed, which will, in the first instance, undertake an alpha stage pilot study to establish a small-scale network using hotspot flood locations known in West Yorkshire. If successful, further funding could be applied for to roll the network out across the region. During the digital discovery phase, we identified some key partners who are keen to continue to support the project closely. These include Bradford and Calderdale Councils, West Yorkshire Fire and Rescue, West Yorkshire Resilience Forum, and the Flood Warden Network. As well as hotspots identified in Leeds, Kirklees and Wakefield, our workshops identified key locations for testing a LoRaWAN in Calderdale and Bradford district areas. The plan now is to carry out further assessment of LoRaWAN and pilot the sensors. To find out more about our LoRaWAN project, you can scan the QR code or email us at WYFLIP@leeds.ac.uk.